Now I would like to say as we go on about other symmetries that there are a few problems, new problems. For instance, for every particle, like an electron, there's an antiparticle, a positron. For a proton, there's an antiproton. And we can make in principle, what we call antimatter, in which every atom has its corresponding anti-pieces put together. For example, a hydrogen atom is a proton and an electron. If we take an antiproton, which is electrically negative, and a positron and put them together, they will also make a kind of hydrogen atom, an anti-hydrogen atom, in principle. It's never been made, in fact, but this is figured out that we could make this. And so we could make all kinds of antimatter in the same manner. Now the question is whether the matter works the same as the antimatter. And as far as we know, it does. And one of the laws of symmetry is that if we make stuff out of antimatter, it'll behave the same way as we make the corresponding stuff out of matter. Of course, if they come together, they annihilate, there are big sparks and everything else. And it was believed that this is true, that matter and antimatter have the same laws. Now the next question is this. Once it's found that the left and right is wrong, the left and right symmetry is wrong, an important question comes. If I look at this integration but with antimatter, an anti-neutron goes into an anti-proton plus an anti-electron, that's an positron, plus a neutrino, the question is the antimatter behave like the matter in the sense that it comes out left-hand thread, or does it behave the other way? And it turns out, we think up until a few months ago, that it behaves the opposite way, and that the antimatter behaves like it goes to the right, where matter goes to the left. And so there was another principle that, in fact, we really can't tell the Martian which is right and left, because if he happens to be made out of antimatter, he'll get the thing the other way, because when he does his experiment, his positrons are coming out, puts the heart on the wrong side. And so you can see that if you telephone the Martian and explain how to make a man, and suppose he makes one and it works. Well, let's make it, and he explained to him also all our social conventions and so on. Then when we go finally to meet this man, after he tells us how to build a sufficiently good spaceship, we go to meet this man and you walk up to him, and if you put out your right hand to shake hands, if he puts out his right hand, okay, but if he puts out his left hand, watch out, because the two of you will annihilate with each other. These are all the symmetries that I have time to tell you about. I wish I could tell you about a few more, but they become more difficult technically to explain. And there are some very remarkable things which are the near symmetries. The remarkable feature of this effect that we can distinguish right and left is that we can distinguish right and left only with a very weak effect, with this beta disintegration. What it means that nature is 99.99 indistinguishable right from left, but that there's just one little piece, one little characteristic phenomenon which is completely different in the sense that it's absolutely lopsided, is a mystery that no one has the slightest idea about yet. Thank you.